Hey guys, so we're back to section 9, number 10 and 11 in the CXC syllabus, and today we're going to be covering this topic here where it says identity of square matrices, right? So basically we're going to look at what the identity matrix is. I assume that's what it's referring to, so that's what we're going to look into right now. So let me just clear this screen and give you the definition for the identity matrix, okay? So essentially, for the identity matrix, let's just draw I here. The identity matrix is equal to, for a 2 by 2 matrix, right? The identity matrix is equal to 1, 1, 0, 0. So the main diagonal is 1 and the other numbers in the matrix are 0, right? So let's use an example of a 3 by 3 matrix instead, okay? So let's say this is a 3 by 3 matrix, 3 rows and 3 columns, right? So the main diagonal is 1 and the other numbers are 0. So this is also the identity matrix for a 3 by 3 square matrix. So for a square matrix, right? For a square matrix, let's say, let's use A is equal to A, B, C, and D, right? A multiplied by its inverse is actually equal to the identity matrix. Cool? So for any 2 by 2 matrix that you have, let me put 2 by 2 below here. For any 2 by 2 matrix that you have, when you multiply the original matrix by its inverse, you should get the identity matrix, right? Which is 1, 0, 0, 1, right? So let's do an example of this to show you exactly what I mean here. It's a little bit confusing, but when you do an example, you'll get exactly what I'm saying. All right, so let's just do an example right now. Let's clear the screen and do an example. Okay, so let's say A is equal to 2, 4, 1, and 3, right? Cool. And the question would probably say, like more than likely the question would say, show that A multiplied by A inverse is equal to the identity matrix, right? And it probably may say and, which is a second part of the question, that A negative 1, A inverse multiplied by A is equal to the identity matrix. And this is also true as well. So let's just elaborate on this. When you multiply a matrix by its inverse, you get the identity matrix. And when you multiply the inverse by the matrix, you should get its identity as well. So basically, these are the two situations where you end up with the identity matrix if you multiply A by its inverse or A's inverse by A. Cool? All right, so let's do the example here. Let's do the first one, right? Let's find the inverse for A, right? And A inverse should be equal to 1 over the determinant of A multiplied by A adjoint, right? So that should be 4, 2, negative 1, negative 3, right? All right, so let's just find the determinant down there. It should be 1 over 4 times 2 minus 1 times 3 multiplied by A adjoint, same matrix, minus 1, minus 3, 2. Cool. All right, so we should end up getting 1 over 8 minus 3 multiplied by 4 minus 1 minus 3, 2. All right, so let's clear the screen here. Okay, so we have A inverse is equal to 1 over 8 minus 3 multiplied by A adjoint, which is 4 minus 1 minus 3, 2. Okay, so we should end up getting 1 over 5 multiplied by 4 minus 3 minus 1, 2. Cool. So if we multiply 1 over 5 by everything in the matrix here, we do a scalar multiplication, we should get 4 over 5, negative 1 over 5, negative 3 over 5, and 2 over 5. Cool. All right, so the inverse is equal to 4 over 5, negative 1 over 5, negative 3 over 5, and 2 over 5. Okay, so let's multiply this now by, let's multiply A by A inverse, right? And remember, A was 2, 4, 1, 3, right? Okay, and let's multiply that by its inverse, which is 4 over 5, negative 1 over 5, negative 3 over 5, and 2 over 5, right? Great. So let's multiply this. Let's clear the screen here for a second. Okay, great. So we're going to continue up top here. So A multiplied by A inverse is equal to, we're going to do first row by first column, right? Which is 2 multiplied by 4 over 5 plus 1 times negative 3 over 5, right? That's the first space. Then the second place is row 1 by column 2, right? Which is 2 times negative 1 over 5 plus 1 times 2 over 5, right? Cool. All right. And the next one is row 2 by column 1, right? Which is 3 times 4 over 5 plus 4 times negative 3 over 5. And the last one is row 2 by column 2, which is 3 times negative 1 over 5 plus 4 times 2 over 5, right? Okay, so we should end up getting A times A inverse is equal to 2 times 4 over 5 is 8 over 5, and this ends up being plus negative 3 over 5, so you should get 5 over 5, right? This is negative 2 over 5 plus 2 over 5, which would give you 0. Then you have 12 over 5 plus negative 12 over 5, which should give you 0 here. And then you have negative 3 over 5 plus 8 over 5, which should be 5 over 5 here. Great. So we end up getting 1, 0, 0, 1, which is the identity matrix, right? Okay, great. So let's just clear the bottom here. Hopefully you wrote off this part already. Okay guys, great. So it shows here that when you multiplied A by its inverse, you got the identity matrix, right? Which is exactly what we were supposed to get. Also, if you could actually do this yourself because the video is getting quite long. So I think you should probably try and do this yourself. Multiply A inverse, right, by A and see if you get the identity matrix, which should be 1, 1, 0, 0, right? So you can check it out to see if you get the same thing. Remember that A was equal to 2, 4, 1, 3, right? So you can find the inverse and you can multiply it by A and check if you get the identity matrix, right? Okay guys, so let me just clear the screen here and let me just do a recap. Okay guys, so just recapping here. Remember, A multiplied by A inverse is equal to the identity matrix, right? Which is 1, 1, 0, 0, right? The main diagonal is 1 and everything else is 0. Also, A inverse multiplied by A is equal to the identity matrix as well, which is also the same thing, 1 in the main diagonal and 0 in the other places. Okay, all right, great. But this is the end of this lecture, guys, and have a wonderful day. Remember, do your best, and God will do the rest. Bye.